Hi class, this lab coming up is the PV equals nRT, or the ideal gas law lab, and I wanted to give you a heads up about the two main errors that occur when students do this lab. It happens every semester, so I'm making this video in the hopes that nobody makes this mistake this time. So this lab that you're going to do is a PV equals nRT lab. It's a gas lab. And it's basically you're testing whether PV equals nRT, the time-honored gas law, ideal gas law, actually works. Of course, it does work. We know it's worked. Hundreds of years of testing have shown it works. But now you get to test it. However, there's a couple mistakes. It's basically two versions of the same mistake that happen all the time. So let's talk about it for a second. First of all, it's PV equals nRT. So you'll be doing things like measuring pressure and volume while you keep the temperature constant, or measuring pressure and temperature while you keep the volume constant. And what happens is as you're doing this experiment, you need to be thinking about what's happening. So for the first experiment, you pull out the syringe to, say, 10 milliliters. I don't know if I get the numbers exactly right, but I think that's it. So now you've got a space there, right? And it's open to the air. So you've got 10 milliliters of air in there, 10 milliliters of gas. Then you connect all the plumbing. You connect this thing to the gas gauge. And you read the pressure, which should be about standard pressure, because it was just air that came in from the room and entered the syringe, okay? So you read the pressure. Then you pull back on the syringe to 20 milliliters. It's the same amount of gas, because you're not letting any more gas in after you set up all the plumbing, set it connected to the gas gauge. Same amount of gas that was in the 10 milliliters is now occupying the space of 20 milliliters. And then you read the pressure again, and then you pull the syringe out to 30 milliliters. Now you've got 30 milliliters of volume, but the same amount of gas. And you keep doing that, changing the volume and reading the pressure. So what will often happen is students will happily record the pressure, and then they'll get home to graph it and nothing's happening. Basically, the pressure versus volume just kind of, whoops. Let me see if I can get that pen again. It just goes like that. The pressure doesn't change too much, even though the volume is changing. So let's think about that. Does that make any sense? Think about, you've just doubled. You've gone from 10 milliliters to 20 milliliters. So you've doubled the volume. What is that going to do to the pressure? It's going to cut it by half, because PV equals nRT, right? If you're doing this at room temperature, this whole piece here is a constant, right? So say it's 20. If P goes up by a factor of 2, then V has to go down by a factor of 2. Or if V goes up by a factor of 2, P has to go down by a factor of 2 when T and N are constant. Now you can see that mathematically, but you can also see that by thinking about butterflies, for example. Say you've got one of these butterfly museum tents, and inside this tent there's, say, 500 butterflies. And then the organizers decide to double the size of the tent, but they still have 500 butterflies. So all of a sudden, the butterflies are less dense, right? By half. There's half as many butterflies hitting you in the head as there were before, because the volume has doubled. So in the same way, if in your experiment you double the volume that's holding that same amount of gas, your pressure better go down by half. And if it doesn't go down by half, then you know that you have a leak in the plumbing somewhere. And this is the super cool stuff. I'll get it. Nope. Nope. Anyway, that stuff is the super cool stuff called parafilm that you can use to fix the leak. It stretches, it feels like wax, and you can wrap it around all the joints and make sure nothing is leaking. So that's the main thing you want to be worried about. For both the temperature and the volume experiments, you want to make sure there's no leak. And here's the second version of that same problem, the problem of leaks. In the temperature part, you'll be using flasks, and they'll be either in hot water or cold water, and you'll be measuring the gas pressure based on the temperature in the flask. And it won't have liquid in there, but there'll be gas in there. And you stopper the flask and connect it to the pressure gauge with these stoppers with holes in them. Now, these stoppers with holes in them, they can be tricky because you see this one has 3 holes, and it came with these 3 little nubbins on the other side. But the nubbins are knocked off when you need them to connect plumbing. Sometimes but here's the issue, is that sometimes the nubbins are knocked off and sometimes they're not. So sometimes you think you have a 2-hole stopper when you really have a 3-hole stopper, and vice versa. So you could have a leak through one of these holes because you're using one hole and you think the other hole is stopped up, but it's not really stopped up. So you've got to be very careful, and again, use that parafilm to make sure, well, first of all, check and make sure you don't have any completely open holes that you're not using, and then use the parafilm to wrap around the joints again. This is, it happens every single time. Somebody thinks they've got a 2-hole stopper and it's really a 3-hole stopper, and air is going in and out between the flask and the room the whole time, and the pressure is, of course, not changing. So be very careful about that. So that's the main difficulty with this lab. You just got to make sure everything's not leaking and your pressure is changing the way you expect it to change. Think about it while you're collecting the data. If the temperature is going up, should my pressure be going up or should it be going down? And if it's not doing what you expect, re-look at the apparatus, make sure everything's set up correctly, and start again. Don't get home and find out that the pressure's just bumping around all over the place and not making any sense. Make sure it's making sense while you're doing the experiment. And have a lot of fun with it, and we'll see you soon. Bye-bye.